Hello and welcome. This is Columbia Basin Research's fifth video in a multi-part series on using Program SURPH. Program SURPH is a program created by Columbia Basin Research at the University of Washington School of Aquatic and Fishery Sciences. Program SURPH, Survival Under Proportional Hazards, was developed to analyze data from release-recapture studies of animal populations, in particular to relate the survival estimates from release-recapture studies to individual-based and group-based covariates. Today in this fifth video, I'm going to show you how to test your hypotheses and use models across multiple data sets. Future videos in this series will run through some examples and offer hints and tips on getting the most out of the program. Alright, so let's fire up the program. SURPH provides two methods of hypothesis testing. Number one, the likelihood ratio test, LRT, and number two, the analysis of deviance, ANODEV. LRT is a standard method to test one model against another. Studies by Smith, 1991, however, show that for models with group covariate effects, ANODEV is the preferred method. You can see more of an explanation in Appendix B.5.1. The relative Akaike information criteria, AIC, is provided to compare models. Relative AIC, delta AIC, is given in the master model list of the likelihood ratio test and the model list of the analysis of deviance. The model with the smallest AIC, indicating the best model, is assigned the value of 0.0, with the relative AIC for all other models being the difference from the best model. If you look here, you can see the likelihood ratio test dialog that appears when you double-click on the LRT on the navigation panel. The top portion is the master model list and shows all current models for which there are results. At the bottom, you must select either survival or detection only for the model type. Here, you can see the results that were created using joint detection and survival modeling. Thus, we select the survival model type at the bottom of the dialog. Then you can select a model of interest on the master model list by clicking on it. A right-pointing blue arrow immediately appears to the right of it, indicating that it is the currently selected model. All testable models appear below the testable model list. A testable model is one that is nested in the master model. A nested model is one that can be derived from the master model by equating one or more parameters or setting one or more parameters to 0. Here, we have selected the model named full in the master model list. The models that are nested in full then appear in the testable model list. In this case, we've selected common. The likelihood ratio test statistic comparing model full with common is 4.4693 with 7 degrees of freedom and a p-value of 0.7244. Analysis of deviance, ANODEV, is an alternative to the likelihood ratio test for the hypothesis testing in SURPH. Appendix B.5 explains the calculations behind the ANODEV. The analysis of deviance is the preferred method of hypothesis testing for testing the significance of group covariate effects on survival, as explained in Appendix B.5.1. The ANODEV action under hypothesis testing on the navigation panel is only available if the current dataset has at least one group covariate and there is more than one population. If you look here, we can see the ANODEV setup dialog that appears when you first initiate the analysis of deviance. As explained in Appendix B.5, the analysis of deviance requires 3 base models at the start. Number 1, the full model. Number 2, the null model. And number 3, the full covariate model. The ANODEV setup dialog allows the user to use the default base models or to select already existing results. When the default option is chosen in the ANODEV setup dialog, SURPH creates the following models and corresponding results if they do not already exist. The full model and results are given the name _full. The survival main effects are set to population interval specific and all group covariates are set to 0. The grand mean model and result, given the name _grand mean, takes on the role of the null model. The survival main effects are set to interval specific and the group covariate effects for all group covariates are set to 0. Number 3, the full covariate model and results are given the name _full covariate model. The survival main effects are set to interval specific, as are the group covariate effects for all group covariates. The underscore in front of the name allows SURPH to identify the models as analysis of deviance models. The models with a name starting with the underscore cannot be created any other way by the user. The detection probabilities and product probabilities in the default analysis of deviance models will be modeled as defined by the currently selected model upon initiating analysis of deviance. If the user wants to model the detection and product probabilities, it needs to be done prior to the starting of the analysis of deviance. If the user selects the Select Existing Results option, the user must select the existing results to fill the role of the null model and the full covariate model. The full model, however, is not selectable by the user, and the model _full will be created if it does not already exist. The model selected by the user must meet the nesting requirements as described in Appendix B.5. Once the model and results have been created, the analysis of deviance dialog appears. Here's an example. The role column, which is the first column of the model's table at the top, labels the role of the 3 required analysis of deviance results. When using the defaults, the _full result takes on the role of the full result, the _grand mean result takes on the role of the null null result, and the underscore full covariate result takes on the full covariate role. The current ANODEV table is shown here. The Copy to Clipboard button allows the user to copy the current table and paste it into another application, such as a spreadsheet or a report. The Reset and Exit button will close the Analysis of Deviance dialog, and when the ANODEV action is selected again, the ANODEV Setup dialog will reappear, asking you to select either the default model and results or user-defined models and results. If the Analysis of Deviance dialog is simply closed, selecting ANODEV action will cause the existing Analysis of Deviance dialog to reappear. In the example here, there are two groups of covariates in the dataset, middle and late. In the default full covariate model, both covariates are included. In order to test the effect of only one of the covariates, we must create the appropriate models and results outside of the Analysis of Deviance dialog. You can minimize or close the Analysis of Deviance dialog and create the desired models and results. To create a model that looks at only the effects of group covariates middle, make sure that the underscore full covariate model is active, and then set the late group covariate effects to the 0 setting. Then select Create Model and call the model full covariate middle. Similarly, to look at the effects of the covariate middle in the first interval, only make full covariate middle the active model and select the middle group covariate effects. Now double-click on Estimate to estimate the results for the two new models. Now reopen the Analysis of Deviance dialog. It should appear as shown, with the two new results shown in the models table at the top. In order to add the full middle covariate result to the ANODEV table, select it in the models table and click the down arrow. Note that if the selected result does not meet the nesting requirements as described in Appendix B5, the result cannot be added to the ANODEV table. Once the new model is added, the Analysis of Deviance dialog will appear, with the new result now included in the ANODEV table and no longer showing in the results table. The model full covariate middle 1 can be added to the ANODEV table in the same way. In order to remove a result from the ANODEV table, select it in the ANODEV table and press the up arrow. The removed result will now appear in the results table. The three required results cannot be removed from the ANODEV table. Now let's look at how we can use models across multiple data sets. Program SURPH distinguishes between a model which defines the parameterization for estimating the parameters and a result which contains the actual parameter estimates from applying the data to the model. This allows models to be used across compatible datasets. Two datasets are defined as compatible if they have, number 1, the same number of intervals, number 2, the same number of populations, number 3, the same number of group covariates and the group covariates have the same name, number 4, the same number of individual covariates and the individual covariates have the same name. The best way to illustrate how models can be used across compatible datasets is by example. Here's the top portion of an input data file for a year 1 of a hypothetical study. Here we can see the data for year 2 of the same study. Since they both have one population and 5 intervals, the same individual covariates and no group covariates, they are compatible datasets. Here is the navigation panel with year 1 data loaded. In this case, the user has used two-stage modeling, locked a detection-only model P_full, and subsequently created 2 survival models based on it with corresponding results. Next, you can load the data for year 2. Here we can see the navigation panel after doing so. Since the two datasets are compatible, the models that were created for the year 1 data are still available and do not need to be recreated. Following the two-stage modeling approach that was used in year 1, the user double-clicks on Estimate under Detection-Only Modeling to estimate the parameters for all detection-only models. This time, however, the user finds that the P_common model best fits the data. Therefore, the user locks the year 2 study /P_common result. The resulting navigation panel is shown here. Notice that the survival model for S_full_P_full and S_common_P_full are grayed out because they are based on the detection-only model P_full and the user has locked P_common for the dataset year 2 study. They are not available to the user for the year 2 dataset. You can now create new survival models based on P_common detection model. This has been Lesson 5 on using Program SURPH, in which we covered hypothesis testing and multiple datasets. Future videos in this series will run through some examples and offer hints and tips on getting the most out of the program. Please note that if for any reason you are having trouble with Program SURPH and these videos are not sufficient to answering your questions, you can find the user manual at cbr.washington.edu/analysis/apps/surph. The PDF manual is there, and you can either load that in a web browser as I'm doing right now, you can download it to view in Adobe. If you're using Program SURPH and you have any questions or comments on that same page, you can give us feedback via our user satisfaction survey. We'd greatly appreciate any feedback you have in helping us make future versions of this program to be more useful to our users. We hope that this video helps you get the most out of Program SURPH. Again, if you have any questions or comments in regard to Program SURPH, please fill out our survey as previously detailed. You can also contact Columbia Basin Research at web@cbr.washington.edu. Best of luck on your analyses and thank you.